You know, another great theorem that's used a lot by artists is the two-transversal proportionality theorem, which is like a mouthful, and maybe artists don't call it that, but they use this mathematical fact all the time. Let's take a look and see what it is together. So if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. In some sense, it's just sort of the extension of the other theorem we just looked at. So in this picture, I have three parallel lines, I have two transversals, and what I discover is that the ratio of this length to this length is equal to the ratio of this length to this length. Pretty cool. Now, we can actually see this happening in real life with an example. I'll put it up here on the side. So an artist used perspective to draw guidelines to help her sketch a row of parallel houses. She then checked the drawing by measuring the distances between the houses. The question is, what is one of those distances? So let me show you the picture. So here's the picture that she produced. And it's labeled, and you can see various lengths are given. And she wants to now see what is this length right here from Q to S. So that's the question. What is the length of Q to S? Well, we're going to use the two transversals proportionality theorem to solve that. So if we try this, we can set up a proportion. Now, what do we have here? So I know I want to find this. And so what I have here is I know this length. That's good. So basically I can say this length is to that length as this length is to this length. But this length I've actually got to figure out. I know this is 6.7 centimeters. I know this length is 4.9 centimeters. And so when I add the two together, I see that this entire length here, UW, is actually 11.6 centimeters. And now let's put this information together. So I see 11.6 is to 5 as the thing I want, which is QS, is to that, 5.8. So now I've reduced this sort of intricate drawing down to something that we can actually look at mathematically. Use the cross product, and so the cross product tells us that 5QS is equal to 11.6 times 5.8, which is 67.28. And therefore, if I divide both sides by 5, I see that QS equals 13.456 centimeters. And so that length right here turns out to be 13.456 centimeters. But you can see the value of this result. The mathematics allows us to figure out how things should look visually and actually informs artists on their aesthetics.